Okay, I'm Mostapha, and
I'm Chris.
we are the co-founders of Ladybug Tools. I assume most of you know about Ladybug Tools, so I'm not going to spend a lot of time talking about what's Ladybug Tools. We are here today to talk about freedom and flexibility to model real-world complexity. And as you can see, there is a change in what we used to put there. Now we have Ladybug Tools plus Pollination that we will talk about that a little bit more too. So Ladybug Tools, different plugins, we try to bring this specialized environmental simulation expertise accessible to more people. And we have Ladybug, Honeybee, Butterfly, Dragonfly, Spider that are covering different aspects of environmental design and simulation. And original reason for developing Ladybug Tools was to address something like this, or to have a response for what people like. You saw Blanca's presentation, how she had the initial graph of like step 1, do climate analysis, step 2, massive study, step 3, do this step 4. And this is how people like to see it until they hit the real world. And this is what happens. You get a project, you do the climate analysis, which is the only one I think you do initially, and it's almost always the same. Then your first question might be like, is an atrium works? Is it good enough here to bring this enough a stack effect? And oh, you need CFD. And what? And then like you just, okay, when I change this, you jump to energy. So you always change between scales and even topics during the design process. And I think we saw a lot of that today during the presentations. And I know AEC Tech is all about Twitter, so I put it in Twitter way, how to start it, how it's going. And I think this code is going really to help us, the topic that we're trying to address, that says for every complex problem there is an answer. For every complex problem, there is an answer that is clear, simple, and wrong. And this is very often is oversimplification, I think, in our industry. And I think indeed it's very costly. And I'll show you one, and that's one of the good things about being last presenter, so I added this slide today. We saw this a lot of time, right, today that says, oh, the initial, when you start the design, cost of change is low, so you can do more change, and you have more opportunity to influence. And then when you get to the end of the design, you have less opportunity, it's more costly. And this is clear and simple. I think it's right. It's a great concept. But then you start to say, oh, because of this, you know what? We have to bring the simulation and studies in the earlier stage of design, which is still clear and simple. And then we say running any simulation is definitely better than no modeling at all. Clear, simple, but this time wrong. And I'll show you why. We basically had to go through like what examples we showed not to get sued. And then we realized like, let's just make a simplified example, and not from real projects, and then like use one from LinkedIn from someone else. So, like we have all these generators coming. Yeah, we saw a lot of them, like now everyone has a generator of buildings, mass, sites, I don't know, like anything. And I think this is a good thing. There are ones that I like more, but that's me. Doesn't matter. What matters is at some point you start asking questions. I think during hackathon it came up a couple of times. It's like, what about environmentals? What about you get enough daylight or something? And say it's earlier stage of design. So let's do a rough low quality study. You want to hit the SDA for 50%, you put 30% window to wall ratio, you run it. Oh, I'm not meeting that. Then you go all the way up to 70% window to wall ratio, and now you're hitting 53%. If you had that study right, with 30% window to wall ratio, you had 50% SDA. And what you have done is actually giving you 100% SDA. So now you made a costly decision of adding a lot of window and everything that comes with it, because you thought, oh, it's the earliest stage of design. It's not that complicated, right? Let's just give it easy. And it's helpful. We have to run simulations. This is another example about CFD. And it's an interesting one that says how, with not having the setting right, less accurate simulation, you can totally go in the wrong direction. And it can go both ways here in this case for outdoor comfort wind simulation. So I fixed this for you. Running any simulation is not necessarily better than no modeling and can be misleading. This is the first step. And this is not to say we think everything should be complex. There is a simplistic approach and there is an elegant simplicity. And the one that I think is going to hurt us and is already hurting us is the simplistic approach. And what we are trying to do with pollination is to get through that complexity and bring some elegant, simple solutions to the industry. So yes, pollination is a collaborative platform that we have been building now for about 2 years. And the goal is to help everyone together make well-informed decisions faster. And I'm happy that it came up during Michel's response, and the collaboration is part of the interoperability class. And how many of you have been through this process like last week, or for the other project that you had? Architect, engineers, or environmental consultants sitting together, we have a deadline, and they're like, okay, we're gonna do this modeling for you simulation. You go away, you develop your design option in one of those CAD tools or Beam tools and all that, right? You send the full thing, you don't hear back because the person is out of office doing a conference like today. They're like, oh, we're working on your project. They usually either clean up your model or redraw everything from scratch. And then, you know, there is a time of like doing preparation, sending it back. And we all know this is one of the people we showed this, that this 2-week round that is hurting them. So you don't get any feedback. When it comes back, you didn't get any feedback. The design has changed, so you can't really use it. And we end up with what we call environmental Photoshop, that you put this environmental simulations in your report as like they look good. But then you say you get there, and you know, like usually you get another email with updated model, you just ignore because you don't have time really to deal with that. And it's not part of your contract. So this is what we're trying to solve. And I want to be clear, running the simulation fast is not going to solve this problem. That's just part of the problem. So how do you do that? To do that, we had to go in and address all the 3 major steps of the process. One was geometry and metadata, the things that you put in your model. Then the other one was recipe. What do you do with those inputs in your model? And finally was results. How do you look at the results, and how do you visualize it, and how do you make sense of that? So what were the solutions that were out there, especially the cloud-based solution right now? One is the one that says, I know everything about your model. Don't worry, you have a BIM model, right? BIM. Boom, gives you all the results that you need. Usually, like the magic box solutions don't ask you for any information, give you a lot of information. Great to, I think, just put in a report. You can't trust anything out of it. It's not flexible. It's not transparent, it's not reliable, and you hit the ceiling pretty fast, because at some point, like, that's all you get from the tool. The other approach is you say, okay, geometry and metadata, now you have more flexibility, you can put your input data in, but sorry, you can't change how it's run, right? Like, it's a black box. If you want to run this black box, this solution that we have, best of luck. Otherwise, you have to start from scratch, develop your own thing to run your custom solutions. Again, not transparent, hard to rely, and definitely not customizable for your needs. So what we are trying to do with Pollination Cloud is to bring this black box out, bring it as a recipe, and then have a cloud service that's ready to execute that for you. So what's the recipe, and why we love recipes and we talk about recipes? For Ladybug Tools users out there, they already should know what's the recipe from the legacy plugins or the new plugins. And it comes from cooking, of course. And we did something wrong initially. And we learned during the process that a good thing about cooking recipes is the description of the problem is separate from the execution. This means anyone can cook. Imagine if you had this solution and you could only cook it with that certain microwave that you had to buy in 1985 from that store, that if you missed it, you can't run it, which is kind of like how our recipes used to be. So learning from that, we separated these two. So recipe is just a description of the problem. And then we have code that takes that and executes that in different platforms as needed. The good thing about that, then you can, from the same recipe, you can run stuff locally on a desktop, and you can run the same on a cloud computing service. The one on the right is running on Windows. The one on the left is running on Linux. We did this during the workshop 3 days ago, and I think it was a very interesting experience. The other advantage of this methodology is because you can run it on local machine, you can do your exploration, you can figure out what the recipe wants to be, and then when you make the decision to deploy it, it will take minutes and everyone will have access to it. I think this is a pattern that we see more and more, like Swarm is trying to do that as an example. And I think it's a good one, but the difference here is because we're not building on top of Grasshopper, it can scale well. So it's not only about giving access to more people, it's also can give more access to more people and can scale with your simulation.
10 minutes left.
Sounds good. The other thing that it will make you possible, now we can resolve that problem of collaboration that we had before, that, oh, I have all these things that I can run, but I don't have that one thing that I need. And now, because my consultant has that, now I have to send all my model there. So now we are removing that. You can share your recipe and include that recipe as part of your solution. So this is how a recipe looks like. I'm going to give like a quick live demo here to just show how things has changed. So these are a list of recipes that we have on the platform. I go with the annual daylight. So now instead of thinking annual, what is annual daylight? You can see every step of the project. You can see the inputs, sorry. Every input that you have here, what are the inputs? You can see what each step goes through. And if you want to know like how we create some path, you click here, you can see what template it comes from, and you can go all the way down to see how the some path is created, what's the command, what's the inputs, what's the outputs. So you can basically see through the process. And why is it important? Because this is a platform now that an expert can see and trust, while if you don't want to go through that level of details, oops, this is how you do it from Grasshopper. Basically, it's a component in Grasshopper that you take. You can go and check the details, you can edit it and come back, but you don't have to. And I think this will solve that problem of making a platform that is loved by experts and is used by normal users. And this also solves this problem of like, similar Grasshopper definitions, but not really the same. Now you have one source of truth sitting on Pollination that everyone in your office can use, and it will be definitely helpful for QA and QC. And similar to what we did with Ladybug tools in Hydra, we are writing the first ones, and we hope the community comes afterwards, and we can build these solutions together. And enterprise will have their own. And it's understandable that will be enterprise solutions that they will not get shared with public. And we actually write some enterprise solutions. Sorry, I'm trying to find this. Yep. That will be hosted for their purposes they use. So we have public and private recipes, and we're also introducing the validated recipes that will help a lot for people who want to get started and have a support system when they get started through the process. So all of this is because we want to solve the issue of interoperability and collaboration, which comes together, right, hand in hand. So we rewrote all the Ladybug tools from scratch. And the reason for that is now if you're using the new Ladybug tools plugins, you are 2 components away from cloud computing. You will have access to it from Grasshopper, Rhino, Archicad. We are developing a Rhino-only plugin, a Revit-only direct from Revit plugin. And we have a web interface, and you can develop your own web interface and use our public API. Or you can do a desktop application and use our public API for running simulations. And one of the ways that we made this thing happen, and I know some people now will send that XKCD cartoon, was we built a new Honeybee JSON format to explain our analytical model. But what we did, we used open standards. And I think this is very important to build on top of open standard if you want your solution to be flexible. And we separated it from the UI or the platform. So now we have a script that takes this Honeybee JSON and converts it to all the simulation engines. And also we use the open API toolset or tool chain to generate SDKs in different languages. We use C# for the Revit and Rhino, and the Python one for the Grasshopper side. And like how open API is, you can develop that for different languages. I'm going to skip this video, but I'm going to show this one. So this kind of shows, like, because of doing this now, how we can have a full, like, energy and daylight modeling interface inside Rhino that you can edit, you can control Z, all this is stuff that you can't usually do in normal energy modeling software. So we are making Rhino a full energy modeling, the energy daylighting modeling capable software. It comes with connection to Grasshopper because now the whole model goes to Honeybee JSON. That means if you want to take this model and bring it to Grasshopper, no magic is needed, right? You bring everything. And for this logic, for example, we add shading to all the facade that's facing south, kind of using the best of Rhino for handling large models and the best of Grasshopper for doing the parametric stuff that before we had them kind of mixed. And we have a Revit plugin now. Why? Because all of them are going to Honeybee JSON. And this means now a Revit model can be generated from Revit. You don't need to bring it to Rhino. You can run the study inside Rhino, like run the Revit energy model and bring the result back. But if you need to, you can bring the model to Rhino and not lose any information. And this is very important for interoperability and collaboration. So those are the ones that we are kind of taking care of now. Ladybug, Sunpath has made its way to FreeCAD, PyPar, and also Blender. And I think this was the result of standardizing all the steps that we showed, and we are very excited about this development. And the other thing is because the recipes are standardized, now you can access them from different interfaces. Doesn't matter where you are, right? You just build an interface that provides the input for them. And I captured a video, I think I'll show that instead of like doing it live, of like how does it look like from the Pollination interface. So this is the NREL building, National Renewable Energy Lab. I have a project that has a WEA file, which is the weather file. I can check the input model, which is the Honeybee JSON format that we just talked about, that has all the information for the model. This has around 250 zones or rooms. This is a large model. And then I'm going to set up an annual daylight simulation for it. So select the project, select the recipe, and I didn't show, but now all the recipes are versioned, so I can go and pick any version that we had from the start to now, and you can see the process. You can select the model, you can select the weather file, and start the simulation. And usually when you have a tool, you start the simulation, you click, you get this progress bar of like, it's running, right? Instead of that, now you get the full process of how the simulation goes. Every step you can check, you can debug, you can see what are the logs. You can, we don't have it exposed in the interface, but you can upload, basically download the artifacts that are generated each step. And this, we showed it during the workshop live, and I captured this video, so wait for it. So it's create all the skies. It creates the octary, which is the format that Radiance uses. And then after this, it needs to split grid and run the simulations. And I think 3, 2, 1, boom. Now it's a scale. So that thing that was running on a couple of machines, now it's running on 500 in parallel. And you can see like the ones that are scheduled, the ones that are running, the ones that are finished. But the scaling, as I said, running the things fast is just part of the problem. The other thing is all the things that are generated, now you can see in that folder structure. So again, the process is there for you to go see and like how we're doing what we're doing. And you can see all the inputs of who is doing what, even in your office. We have all the inputs also in a different tag. So when you come back to this project later on and you don't remember how you ran it, all the inputs that you put in this model is also there for QA, QC to make sure the model is good. I don't know if that has happened for you guys, but it happened for me several times that I leave a job and then I get this email up like, the client came back, where is that thing that you ran like 2 years ago when you started? I'm like, I have no idea. But okay, and you can see like how it is scaled up in Spanner. And that's not gonna happen anymore because if you wait for it, this is the result of that simulation, because now you can basically take everything and bring it down from Pollination and recreate the full model, inputs, outputs, and results, and the process itself. And this is hopefully is solving the problem of collaboration that came up several times. So remember this one, now this is how we can work together. Headline again, this time instead of like, what are you trying to model? Instead of send me your model, it's like, what are you trying to solve? And then you write a recipe, you share it with your client. Client works with the recipe, test it, give feedback. Second version, feedback. At some point, you don't hear from them, which is a great thing usually. And then come back and say project was done. These are the improvements we want. You deploy your version 1.0. I showed you the interface, how that works. And you get all this extra bonus on the architecture side. You get this freedom and not doing the thing over and over on the engineering consulting side, which will resolve this thing. It's not only about technology, right? It's about people, it's about different practices. And how Ladybug Tools and Pollination together are trying to resolve this, if I want to put it in a single slide, is like this. So you have your architect, people who work with CAD, being uncomfortable there. Still, they can do that. We have an analytical model which makes it better than what it used to be in Ladybug Tools. Then you have simulation recipes that you have access to that you can run. You can run it locally as fast as your machine gets, and then you can get the result and visualize it. So this is there. This is staying there. Pollination brings the extra recipes, so now you have access to more recipes that people can do. It brings a viewer, 3D viewer, to help you with QA/QC. It helps you run simulations faster now, and you can, of course, do result visualization. And this is something that we just started recently, that not only you want to do 3D and on your geometry, but you want to do 2D web-based analytic dashboard, custom ones, which means now this person who is interested in dealing with recipes and make sure that the recipes are correct and updated doesn't have to go through CAD tools that they don't know how to use. This manager who is really interested to see what are we running and if we are getting better or worse, they can just go to the data analytics. This person who is checking the result can have a dashboard that's only using for QA/QC. So basically this platform, this UI is bringing different practices and different people to speak the same language, which is the key for collaboration. And we get always this question of, okay, what's your roadmap? I don't know if you have a roadmap. You have an evolution process that I can share. As the steps that we're going through is, one was cloud computing, run simulation faster. The other one was recipes, deploy expertise as an executable, reproducible units. Then it was lens, which is we are getting to, which is making sense of that data. And finally is the concept of apps, which we want to bring all of them together. So the idea is, can we make it easy for people and convenient to build their custom apps ready to be executed on cloud? Basically, you go all the way from freedom and flexibility to all here convenience and less control. Like, you should have the choice of where you want to get in the process. Put it back again in Twitter mode, how to start it, and how it's going. So we started as a handful number of components in Grasshopper plugin, and now we have a cross-platform cloud-enabled solution that can be accessed from almost all the major CAD environments. And hopefully that will bring enough freedom and flexibility to you to model the real-world complexity. With that, we have to thank the Department of Energy because of the SPIR award grant that made most of the work that we are doing possible. And also thank you for staying around. This is the last one. And I don't know why people usually put us the last presentation these days, but I take it as a good thing. If you want to get early access, we haven't opened early access yet, but that's the link. Go apply for early access. If you want to be updated with what's going on, follow us on LinkedIn at that link. Thank you so much.
Fantastic, Mostapha.
Thank you, Ben.
Pleasure. Yeah, I'm honored to moderate here. So much to chew on, and you guys have been, it's been a long journey for you. Even this weekend, I mean, starting in the VIP on Thursday, all the way through. I was in the workshop Friday and today. I mean, really, really impressive. So I guess start with congratulations. So any questions, please feel free in the chat or the QA. I'll start with a couple just to warm up. I mean, we struggle with the ease of use versus complexity too, right? Core Studio is trying to do, I would say, sort of a similar thing, right? Like we want to build engineering as a web service, just like you want to expose similar kind of parts of environmental design and simulation now as a web service. Super exciting. And I like Ladybug, Honeybee, all the way along. You've all managed to you don't dumb it down. You've kind of both made something super sophisticated and widely used. So I don't know. That's unusual, I suppose, in AEC. I wonder if you could. It's a tough ask, but do you think you know why? Can you give us a little hint? What is there a correlation there? Is it because it's so sophisticated that it's so widely trusted, used, adopted, or is there something else, some secret sauce you all keep to yourselves?
I can take this start at least on this one. I think it goes through our methodology of evaluating every step of the work that we do. I think something that we do reverse is we do expert first design and go back to normal user. Unlike a lot of platforms that say, oh, you want a lot of users, so make it easy so everyone can use it. We go and ask the first question is it good enough for an expert user to look at this and say, I can trust this, let's use it. And then after that, we think, okay, what are the things that a normal user, we can safely put some default value and say, it's okay, they don't need to have access to it, and it still gets something reliable. And I think this is something that Chris and I and everyone on the team, we just go through this over and over of how simple we want to make this without losing that thing of you look at this and say, this is still good enough, I can do it, this is flexible enough, and I can see through the process. So that's good.
So fantastic. This new kind of breed came up earlier. I don't know if you saw the morning sessions, but it came up on Thursday. And again, Gonzalo brought up this new generation of designers, engineers, architects who are very computationally savvy, right? They're comfortable, as comfortable hacking in Python or consuming an API as they are, kind of designing in Rhino. How do you see that new competency in the market changing software development in AEC? Do you see it? It seems to me you're all starting to target that. So that sort of set that people. Is that happening anywhere else? Is that correct? Are you actually going after that kind of user?
Chris, you want to take this?
Well, sure, yeah. Well, I can say yes, but not exclusively, right? I mean, definitely like Mostapha just mentioned that we try and do it expert first and go after those people who want to dive deep into the guts of what's going on and understand it. And I think an important thing to recognize with that is that by sort of engaging with those people first, with those those more advanced users, that they not only do you get validation that what you're doing is actually up to the standards of these experts and people who want to get deep into the process, but those people who engage with it and who come to trust the software will bring in 100 more people, right, helping educate them about the software. And I think a lot of our success we owe to that sort of positive feedback loop. That we make it first for the experts, and then once they say it's good, then we can expand it. And if we've done a good job, then the experts will help us.
Awesome. Okay, we got a question from Luis. Oh, this is a good one. Do you think machine learning and environmental design has potential? Right, some of the problems you all face are inherently long solve problems. This idea has been around for a while with stuff, all right? We've seen various attempts. What's your take here? Is this an evolutionary offshoot? Is this something you're all working on?
Well, we are not working on ourselves, but we are empowering people who are working on it. So that layer 5 Theodore ran those simulation for daylight factors using the legacy version of Ladybug tools to generate them. I'm personally think we as a platform, we like to get there, but again, being very careful about what we are presenting to the market and what's the result of that. I want to wait and see where we get, because, you know, like I think is a for well-scoped problems, they're great using these tools. Like, yeah, if you want just know like a 2D that they have and say like, we generate the geometry, we can have a very good guess about like how the daylight will look like. It's a geometrical part, especially if you do daylight factor, right? What gets dangerous is just you just put this out there and people forget that, oh, it was supposed to be only 2D, only daylight factor, right? Then you see it just goes everywhere. It's like, and people call, we did this radiation. It's not even radiation, it's daylight. And I'm going on this rant about like fast food versus, you know, like well-cooked food these days. I kind of like think the whole industry is not, there is a hunger for environmental studies and other technologies, right? And the hunger is one way of like to see this hunger is like, hey, we have all this fast food things for you. It's so greasy, you eat it, you feel good at the point, you know? And you see like the startups pops up every day with fast food solutions. And we will see more because there is a market for that. And financially it makes sense. The challenge or the issue is if you wait a little bit, people are gonna get cancer. Buildings who are fit by fast food studies going through the way, they're gonna be like, they're gonna fail, like simple. Like I know it because I have done this, right? Like, and as an expert, I think, and the whole company, we can't throw that path. So is machine learning helpful? Yes, definitely is. It's a nice technology to look at. But I think we are concerned in a way to say like, can we build a scoped app in a way that's saying like, this does this and this does it well, it doesn't do anything else. And there are like 20 warnings of like, this is not this is not that. And at that point, it will be great, right? And I think it will take us take us a while before we get there. But again, we are in the business like empowering people to do that. So we're building a platform that you can run machine learning on pollination without having the limitations of computation. Yeah. If that's the question, we'd like people to do that.
Outstanding. Any other ones? Questions, folks? I think we have some time. Maybe I'll try one more. So, you know, freedom and flexibility. I think you helped teach me this along the way, Mostapha. Like freedom, there's always like kind of a hidden layer there. Could you all like maybe talk about some of the like, externalities, some of the hidden costs that come along with shepherding a kind of a community like this over the course of years? This might be a personal question. You know, if we got to take it offline, I'm happy to. But you know, Leland brought up recently that you know you've all managed to kind of like really develop consensus in a kind of an adversarial environment, right? AAC is hyper competitive, and you know, kind of posited your model as a way of starting to pool data or knowledge for other problem domains, not just environmental design. Maybe if you don't give us the skeletons in the closet, would you give some advice?
I mean, for sure. I think like we have going through this analysis, I think every year. So this year was for fast food, but 2 years ago was about the tree and branches. And, you know, like you have the root, you have the main, Chris probably can do this better than me, main trunk, and then you have all the branches that comes out of it, right? And one thing that we have been doing and we have telling other people to do is, let's build this root and the trunk together. Let's compete on the branches. And you know, like the way we build the community, I think is the same thing. And I think it goes to that question that you asked before too. Like, so when we put time on something, or we want to do something, they always, one of the questions is like, where does it stand in this tree structure? And which one, we know when we put on a like a time on the root and the trunk, people don't pay for it. You know, a normal industry doesn't pay for it. What we get back from it, from our community, this is something that you won't know, right? Then going back to that food, this is something that I'm taking care of for you, so you don't have to be concerned about it. Like a healthy thing to put in. So the result, the fruit that comes out of this tree is high quality. And yeah, I mean, it has a cost. I think Chris can talk to it too. Like it takes a lot of patience. it takes a lot of compromise, and I think it takes a lot of being open to listen to people and let them, you know, especially when people come in. I mean, some of the best people who we have now in the community are the ones that have been, you know, the most critic of how we have done it, especially when they start, like, you know. And then when you have this conversation, you see like people who really care. I think like what we care, we can make a difference, and I think that has been the process. And I know, like, I think this is a topic that definitely Chris has a lot to share.
Yeah, yeah. I mean, I can definitely say it's definitely tougher to, or it's like, you know, there's less examples necessarily to pull from when you're trying to bring both the community and start a business together. But yeah, I mean, time and again we see that like it really pays off. You know, it's a more investment to keep, you know, to make sure that the community is thriving and supported, and you know, in the way that it is. While still trying to support ourselves. But yeah, you know, the input that we get from those experts is, you know, hard to put a price on that for sure. Right. And the, you know, as we mentioned, that whole sort of positive feedback loop we have of experts not only helping us make the software better, but of then helping to expand the community and you know, expand awareness of it, and yeah, and to do policing too, to make sure people apply the software correctly. Right?
I mean, I should add another side of the way we do stuff. It's not investor friendly. I should say that. So if you're looking for like angel investors, like VC, this is not going to get you that long unless like because you have to make changes because they want to see the hockey stick. And this is a little bit of like, you know, like this is like the rabbit way, that's the Churchill way of going, like how we're going. You have to be slow and steady. You have to look your financial in a way that you understand, like that works with this model that you have, because everyone talks about optimization. So this is not like when profit is the target, right? It's different from when you put profit as a constraint. So that's how we work. Profit is a constraint. We have to make money to be able to go forward, and we understand that. But then when we make decisions, we say, okay, there is a place, you know, and that's not what an investor like to hear. There is a place that say, this is good money for us with this size to continue for a couple of years, and we can do this and this, and it come in. But yeah, like I should say that too. It's not like everything is great, you know. You make decisions. It comes with some responsibility. It has, you know, results. You have to take both sides in consideration if you want to do what we do. Yeah.
Well, you guys are the closers, whether you like it or not. We do want to do what you do, and you know, I think you really just nailed it. I mean, there's a reason. It's the theme this year is commonalities, and again, like it's always a balancing act, right? We heard about that. Clifton talked about that today, and I think your comments just now really nailed it. So that's why you guys are the closers. Don't question it.
We'll see. Like last year, I mean, we came back. When was it? Like last time, like 2 years ago or 3 years ago, I think we had that panel, you know, and we were back. We were still doing fine. I think the things that I said that time still, I think it's working. So yeah, hopefully we'll be back again, and like we see, like we share our experience, what we have been through. Yeah, so far so good. I hope, and I hope really like we can get pollination out there sooner than later. I really think like what Ladybug tools that pollination can do, like in a scale, because not because it runs, but because now like it's easier to access, it's easier to and it's built for collaboration. I think great things can happen, and that's the thing that like keeps me excited to do this. At the same time, that's the thing that we know there are like part of that root and trunk needs to do more, a little bit more before the release that kills you too. So, you know, like you want to put it out there, but you're just like, if you do this, there will be issues. We'll get there. Like we're very close, as you see during the workshop.
Really impressive stuff. I did see during the workshop, if I could plug a little further, it's pretty amazing stuff. Congratulations, guys, and thank you again.
Thank you. Thank you for having us. Great to be back always.